All right, just a quick little example here. I wanted to run through an example showing all three market structures in the same question. So that's what we're going to do in this little example. So we have a demand curve, which is price is equal to 200 minus 1/2 Q. And then we have a bunch of firms potentially. We're going to start off with one firm, and then we're going to increase the number of firms. But every firm looks identical. So we're going to say the marginal cost curve for each firm is 20 plus Q. So no matter how many firms are in the market, they all look identical, and they all have this exact marginal cost curve. But so what we're going to do is start off in a monopoly, and then we're going to jump to a duopoly, so one firm entering. And then we're going to consider the long run competitive market. So a bunch of firms entering, and what does this do to the firm and to the market? All right, so the monopoly, we need a marginal revenue curve. If you've done some calculus, you know how to get this, at least in theory. This is just how much revenue does each additional unit bring in for the monopolist. And it looks like this thing. It comes from the demand curve, but I will always give this to you in a question. And then the quantity for the market is just QA. So there's only one firm in a monopolist. And then we also have a duopoly. So we're going to move from monopoly to duopoly. The marginal revenue curve for the duopoly looks a little bit different. So in questions like this, like with monopoly, I'll always give you the marginal revenue curve. So for the duopoly, the only difference is that because buyers can switch to the competitor down the street, our revenue curve depends, at least in part, on how much our rival is producing. So we have QB in the marginal revenue curve for firm A, which is represented here. Then we also have the marginal revenue for B, which is just really the symmetric form for firm B. So these two firms are symmetric. And like before, the marginal cost for both of these firms will be identical. So the costs and the revenues look identical for the two firms. So we say those firms are symmetric. And then in the competitive market, we know what the marginal revenue curve is. It's just going to be the price. So all we need to know is the supply curve or the price. You'll see some other questions I've given. I haven't given a supply curve, I've just given a price, which actually, it may feel a little more confusing, but it makes the work a little bit easier. So sometimes I like to do that. Okay, but here we have a supply curve. So these are the three market structures we're going to examine, and you can see this is really just the same, basic fundamentals of the sellers and the buyers. The only thing we're changing is when we go from monopoly to duopoly, we're adding another seller, and then duopoly to competitive, we're adding many sellers. But the idea here, doing this example this way, is that we can see how the solution concepts in each of these three markets is identical, or very similar at least. The core ideas are the same across all market structures. The way we solve them have slight differences, but the core idea is very similar. So let's just go ahead and solve this thing. So in your notes, you'll have the core solution concept, which maybe I'll put it up here. The idea is that firms aim to maximize their profits. So we call this the firm's problem, which is essentially just we want to pick quantities and prices in a way that maximizes profits. And the way we write this is just sort of in optimization notation. So this is just maximizing. We're going to choose quantity. And then remember, capital Pi is our profit. So this is just the difference between total revenue, how much we're bringing in, and total cost. Nice. And then the way we solve this is we set marginal cost equal to marginal revenue. And this is the thing that gives us our Q star. So no matter what firm we're dealing with, whether it's monopoly, duopoly, competitive, whatever, firms are setting MC equal to MR. This is a general principle we want to pick a quantity where we can't do better by adding another unit or subtracting another unit. Okay, so then the second step is we take this Q star and we plug it into the demand curve, whatever that demand curve is, and that gives us the price. So we'll talk about this in the context of monopoly, duopoly, and competitive. It looks a little bit different, you know, the actual like mathematics of this in the different market structures, but the idea is identical in all three. All right, and then we're not going to do average total cost here mathematically, but we're going to plot some things. So we have ATC star, where we say we plug in Q star into the ATC curve, which gives us ATC star. So this is just finding the average total cost given, you know, what the average total cost looks like, and then we plug in Q star to find that specific one. And then all of these things together give us enough to find the profit for the firm. So this is price minus ATC star. So these stars just represent, you know, these are the prices and costs at our Q star. And then for the competitive firm, we're not going to talk about entry and exit dynamics, but the last condition here is we say if P star isn't negative, then we stay or enter. If this is greater than 0, we stay or enter in the long run. And then if profit is negative, then we exit. Okay, so this is our general solution concept, and we're going to apply this to all three market structures. We're just going to see how these things sort of play out in parallel, slightly different ways in all three of the markets. All right, so nice. So the first place to start is going to be with monopoly. So we have our marginal revenue curve, and we have our quantity. So the place I always start with these things is I'm just going to make a nice little picture. A picture is just an unfancy term for a graph. So on the vertical axis, we have price. Horizontal axis, we have quantity. We have our downward sloping demand curve. And we have our marginal revenue curve, which is just twice as steep. So it looks like this. This is MR. And then we have our marginal cost curve for every firm, including the monopolist. So we know what the monopolist faces for their marginal cost, which looks something like this. So we have 200 is the vertical intercept for both the marginal revenue and the demand curve, and then 20 is the vertical intercept for the marginal cost curve. All right, so this is nice. This is our basic setup. The first step for solving this is to set marginal revenue equal to marginal cost. So all we're going to do is intersect marginal revenue and marginal cost, and that tells us where on the horizontal axis Q star will be. So we'll call this Q star. And then I'm just going to follow these steps graphically, and we'll talk about them graphically first, and then we'll go through and solve them. So vertically, we run Q star into the demand curve. So we plug Q star into the demand curve, and that gives us P. So that gives us this thing, P star. This just tells us, you know, we want to produce Q star. That's our profit maximizing quantity. What's the price that we can sell everything for that is highest? What's the highest price that clears the market? We can sell everything and still get away with the highest price. And that happens exactly at the demand curve. All right, so that's price from Q star. Now, we're not given any information about ATC, so I'm just going to draw one in, which makes our lives pretty simple. We'll just call this ATC, just an example of an average total cost. The shape doesn't matter so much, but this gives us our ATC star. We plug Q star into the average total cost curve, and that gives us ATC star. Okay, So nice. So this is a lot of information we need. And let's plot profit. So profit will be the difference between price and average total cost. So it's this thing. And then we look at that difference for all of the quantities. So that runs all the way out to Q. So this is our profit. Nice. Cool. So this is most of the graph. Sometimes I've asked for deadweight loss, which could happen out here. Actually, let's do it in yellow just to keep it unobtrusive. It's not the main thrust of what we're doing today. Okay, so maybe you can see that on the screen, but deadweight loss is just that triangle. We want, if we were socially efficient, we would want a quantity here. And so this is our QSC, social planner. And so we would want the difference between these two. And then we just look at marginal benefit and marginal cost, which would give us the deadweight loss. But we're not focusing on that in this question. All right, so we have our whole graph. We know the different parts. Now we need to solve for some numbers. So the first step is to find MC equals MR. So this is step 1. MC equals MR. So our MC curve is 20 plus Q. And our MR curve is 200 minus. And so I've called this this capital Q. It's just everything in the market, but it's also equal to QA. So I'm actually going to cross this out and call it QA. So then our marginal revenue curve also has QA. All right, so the idea here is just the quantity in the market is everything that the monopolist is selling because there are no other competitors. So that's why we can substitute into the marginal cost curve the individual quantity. Quantities are all just QA for the monopolist. All right, so nice. So we can just solve for this thing. So we have 2 QA is equal to 180, and then QA is equal to 90. So this is our Q star. This is Q star. Nice. So we found Q star using our general process. The next step, step 2, is to find the price. So all we have to do is plug Q star into the demand curve, and that gives us the price. So the price is equal, from the demand curve, it's 200 minus 1/2 times Q star. And we know Q star is 90, so we'll just plug this in. We get 200 minus 1/2 times 90. So price turns out to be, our P star, is 200 minus 45, which is 155. Okay, so nice. We have price, we have quantity, and if we wanted to, we could go ahead and solve for ATC and price and the rest of this. But we've done the main mathematical work here. So the rest is just to graph it. So 3 is just ATC star on the graph. And then 4, we have profit is on the graph. And then step 5 is no entry because it's monopolist. All right, so nice. So this is the monopoly solution. So the next market structure we're going to look at is the the duopolist. So let's start it up here maybe. So the idea here is, we're given two marginal revenue curves. Each of the marginal cost curves looks the same for each of the firms. So we know this is symmetric. So I'm just going to write this over here. Symmetric. So this means that QA star is going to be equal to QB star. This isn't always true, but I'm only going to give you questions that are symmetric in this class. But if you have more interest in studying these things, you can see more, oligopoly, duopoly questions where we don't have symmetry. You can see those in other classes. But for this class, we're going to keep things simple and just use symmetry. All right, so just like we did for the monopolist, we're going to set MC equal to MR. So for firm A, remember we have two firms, we call them firm A and firm B. For firm A, we have marginal revenue is equal to marginal cost. Marginal cost A. So marginal cost A is just 20 plus QA, just how much it costs us to produce. But then marginal revenue A is 200 minus QA minus 1/2 QB. So the complexity here, the reason this is game theory, is we have strategic interaction. My payoff, what I should do, depends on what you're doing. So all we're going to do is solve for QA in terms of QB. So this is, so on one side we have 180 minus 1/2 QB. And then on the other side we have, so we have 2 QA. I'm just going to flip this around. I like QA to be on the left-hand side. So we have, and then I'm going to divide both sides by 2. So this is QA is equal to 90 minus 1/4 QB. This thing is the best response for firm B. I'm sorry, for firm A. So best response for firm A is this thing. So you can tell this is the best response for firm A because we've optimized firm A's quantity. You could rearrange this so that B is the Y variable, but it would still be the best response for firm A. And the reason is because we've optimized for firm A. Okay, so nice. This is the best response for firm A. And because this game is symmetric, we can also write out the best response for firm B. So this is QB is equal to 90 minus 1/4 QA. And the reason we can do this is because it's symmetric. So we don't have to do all of this work again. We can just flip the subscripts. Symmetry also gives us one other important idea, which is that the quantities of the two firms in equilibrium, in Nash equilibrium, will be equal. So we have these two best responses, and the picture we can draw is, so we have QB on the vertical axis and QA on the horizontal, and we can draw these two best responses. So this is the best response for firm A and the best response for firm B. This thing is the Nash equilibrium. So our Nash equilibrium which essentially just tells us what are the quantities where neither firm playing against each other would wish to unilaterally deviate. Which quantities tell us that both firms are going to be happy. Neither firm wishes to switch. And we can find that by intersecting the two best responses, right? The best responses are telling us what we should do in response to the other player. But if we play them against each other, then we know both firms are happy to be doing what they're doing. So we have Q star A and Q star B. And so we want to find these things. But by symmetry, we know that these two quantities are going to be equal. So this gives us a really simple way of solving for these two quantities. We can take QA and set QB equal to QA. So this is QA star is equal to QB. Nice. So this is valid because we know it's symmetric. If it were not symmetric, we would not be able to do this. Remember, the way we generally solve these things is we take the best response for the other player and plug it in to the best response for the first player. So that that would be QA is equal to 90 minus 1/4 times 90 minus 1/4 QA, close parentheses. But here we can save ourselves a lot of work. So we'll just write it this way. And this gives us 5/4 QA star is equal to 90. So then QA star is equal to 90 times 4/5, which, if my calculator is right, this comes out to be 72. All right, so this is all step one. We also have QB star is equal to 72. So these two things give us the solution to step one. So we found our QA and QB star. Step two is we're just going to take the quantity in the market and plug it into the demand curve. So we have our demand curve. So we have P is equal to 200 minus 1/2 times Q. But in this case, our Q is equal to QA plus QB. Remember, Q is just all of the firms in the market. We have two firms here. So this is QA plus QB star. So that's 72 plus 72. And this thing is, I'm going to simplify this, 144. And this comes out to be, so it's 144 divided by 2, so that's, so we have P star, so that's just 72. So 200 minus 72. And this thing comes out to be 128 is our P star. Okay, nice. So we have price, we have quantity, and we could continue going. But before we talk about competitive markets, we're going to do a little bit of comparison here. We're not told anything about ATC, and typically we don't, at least at this stage, we don't do a lot of graphing of costs. We could if we wanted to, but we're not going to do it in this class. We could take the costs for the two firms and plug it into their ATC curves if we wanted to, but that's not the step we're going to take today. But let's do a little bit of comparison here. So in total, so Q is 144, just the sum of the two firms, and we can compare that to the quantity in the monopoly. So you can see we've added one firm and we've increased the quantity available in the market. So this is very nice in general. Remember, we would wish to increase our quantity from Q star for the monopolist to some QSP. And what we've done is we've actually increased quantity simply by adding one competitor. The other thing we've done is bring down prices. So prices have gone down from 155 in the monopoly to 128 with a duopoly. So what this competition has led to in the duopoly is more is available and at a lower price, which is generally a good thing. Remember, the monopoly, high prices aren't necessarily a bad thing, but we've concluded from the monopoly that we would wish to produce more from a societal perspective, and we would wish to lower the prices. Okay, so that's exactly what we've done with the duopoly. For the competitive market, we're going to say not just do we have two firms, but we actually have many firms who are identical, selling exactly the same thing. So this is our competitive market. And just like the duopoly, we're actually in the background assuming that firms are symmetric. So there are some ways of adding nuance to this, but in this class we're just going to keep things simple, and we're going to say that firms are symmetric. Everyone looks basically the same. Okay, so we're also given a supply curve, so we'll use that idea. And the reason we need to use the idea is because we actually need to know the marginal revenue curve. So you'll remember the picture. For the firm, we have a marginal cost curve, which we're given in the question, which looks like this. So marginal cost starts at 20 and goes up by 1 for every Q. And the marginal revenue curve is just the price. So we need to look to the market. So on the vertical axis, we have price, and this is the market. We need to look to the market to tell us what the price is. So this is our supply curve, this is our demand curve. So our market price is this thing. So this will be our P star. Eventually we'll find what that is. And then we have our Q star, big Q star, which tells us how much the market is producing in total across all the firms. So when we had one firm, that quantity was 90. When we had two firms, that quantity was 144. And when we have many firms, that quantity is probably going to be a lot larger. All right, so we have the price in the market, which tells us the marginal revenue curve. Remember, when a competitive firm raises their quantity, because they have no impact on the price itself, all they're doing is increasing their quantity times the price. So their revenue goes up by 1 times the price. So our marginal revenue curve is just the price itself. So when we find the Q star for the firm, all we're doing is intersecting MR and MC, which gives us our Q star. And we'll talk about profits in this market in a little bit. But this is the core picture. All right, so let's go ahead and solve this thing. So before we get to step 1, we have to actually find what the price is. Sometimes I've given the price and not the supply curve. Here we have the supply curve, but not the price. So maybe we'll call this step 0. We're going to find the price. So we're going to set the supply curve equal to the demand curve. So we have 200 minus 1/2 Q. And we're going to set that equal to the price from the supply curve. So this is 20 plus 110 Q. All right, so we have 180 is equal to 1/2 plus 1/10 Q. Okay, so this is maybe a little bit more algebra than just being given the price. So we'll just simplify these fractions. So we have 10/20 plus 2/20 Q. So this is 180 is equal to 12/20, which if you simplify this out, this is equal to 3/5 Q. All right, so we have 3/5 Q on one side and 180 on the other. I'm just going to flip the relationship and simplify this. So this is Q is equal to 180 times 5/3. And this 80 divided by 3, and then we multiply it by 5. Let me check my notes. You can also plug this into a calculator and get what you need to. This should come out to be 300. Yeah, so 60 times 5 is 300. Okay, so nice. So this is Q star. So this is our market quantity. So that's this thing. But then we also want to know the price. So the way we find the price in markets like this is we just plug the quantity back into the supply curve or the demand curve, depending which is simpler for you. Here, I think the supply curve is going to be a little bit simpler. We have 20 plus 300 times 1 over 10, which is just 30. So this is 50. All right, so our equilibrium price in the market is 50. Nice. So then for step 1, what we're doing is we're setting the marginal revenue curve equal to the marginal cost curve for the firm. So this is also the marginal revenue curve. So we set 20 plus Q is equal to the marginal revenue for the firm, which is the price from the market. So then we'll just solve this thing. So Q star for the firm is equal to 30. We'll put a box around this. So nice. So this is the quantity the individual firm produces when there are many buyers and many sellers. So the market quantity is 300 and the individual firm's quantity is 30. And what this can actually tell you is the number of firms in the market. We haven't really talked about this in class, but this would tell us that because there's 10 times the individual firm's quantity, that there are actually 10 firms, which is sort of a small number for a competitive market. All right, so this is step 1. Step 2 is to find the price. Well, we've already sort of done this. The marginal revenue, in some sense, is the demand curve for the individual firm. Because the firm is simply taking from the market the price. The price the firm will charge is just equal to the marginal revenue curve, or the price that they're being given. So this is 50. All right, so let's maybe just put our last 3 steps for completeness. So the next step is to find ATC star. Well, again, we're not given any information about the average total cost, but I'm going to draw it like this. ATC. So what this tells us is that we have 0 profits in this market. Firms are operating at a quantity where the marginal revenue is equal to the average total cost. Or another way of saying that is that the marginal revenue, or sorry, the price is equal to the average total cost, which tells us in step 4 that profits are equal to 0. And this is our long run equilibrium. And the reason this is our long run equilibrium is because that tells us with 0 profits that no entry or exit. And the way I've set up this question, there's not really enough information to know that. But often the context of the question will tell you whether there's a long run equilibrium or not. Here we see that there's not enough information to know, but like in many of the examples I've given, we've talked about no entry or exit, which is a clue that there's no profit to be had. So if you don't see any entry and any exit, then there's no profit or loss, which means firms are making 0 profits. Okay, so what this example is intended to do is show how this general approach applies in many different types of environments. And what we've been able to show is that as the number of firms have increased, we've gone from 1, where we have a quantity of 90 and a price of 150. We've added 1 firm, which has increased the quantity from 90 to 144 and has reduced the price to 128. And then as we've added many other firms into the competitive market, the price has gone down from, by more than 3, a factor of 3, and the quantity has gone up. So it's gone up from 144 all the way up to 300 in the competitive market. And these are the directions that we like to see. We've essentially reduced our deadweight loss. We've moved towards the core results that we've talked about all semester in Part B and in Part C. And this is a very nice thing. All right, so there's more to say, but I think we'll leave it here. I will see you in the next one.